in Poisson distribution, we have calculated constant values with the help of the Poisson distribution. We have done some questions related to the Poisson distribution. In today's video also we are having some more questions. For the practice of the Poisson distribution, these all questions are from the examination point of view, it's very important, and I have seen in examinations question paper these questions, that's why I have taken this question in this video. So the very first question related to the Poisson distribution, one book contains 100 misprint distributed in 200 page. What is the probability that page observed at a random having at least 2 misprint? Okay. One book having 100 page and number of misprint are 200. 200 misprints and pages are 100. So arithmetic mean of this, that is 200 misprint, pages are 100, so average 2 misprint in every page of this book. Againly I am repeating the question, but book have 100 page and the total misprint in that book is 200. So the average per page mistake is 200 divided by 100, that is 2. So m value is 2. So e raised to power minus m, that is e raised to power minus 2. We will see the table value for the e raised to power minus 2. We will have available the value, so we will not waste the time in this. That is 0.1353. Now we are to calculate that for we observed a page having less than minimum 2 misprint is over there. A book contains 200 misprint distributed randomly throughout the 100 page. Then what is the probability that the page observed at a random contains at least 2 misprint? At least 2 misprint. At least 2 misprint. So this is probability of x at least 2, that is 1 minus probability of 0 misprint plus probability of 1 misprint and probability of 2 misprint. At least 2 misprint is asking, so 1 minus probability of 1 and probability of 0. At least 2. At least 2 or more than 2 misprint is over there. So there may be 0 misprint page we will detect, 1 misprint page we will detect. So remaining will be 2 or more than 2 is over there, at least 2. So 1 minus e raised to power 0. So that will be e raised to power minus m, m raised to power 0 upon factorial 0, e raised to power minus m, m raised to 1 upon factorial 1. So that is 1 minus 0.1353 2 raised to power 0 upon factorial 0 plus 0.1353 2 raised to power 1 upon factorial 1. So that is 1 minus 0.1353. In solving this, 0.1353 multiplied by 2, 0.2706. So 0.2706 plus 0.1353 minus 1. So we are answer, that is 0.5941. 0.5941. Againly we have to check this. For 0 misprint and 1 misprint, okay. So that will be 0.5941. 0.5941 or having 59.41 percentage is over there. So in this question, one book contains 100 pages having 200 mistakes. So the average per page mistake is 2. So we will calculate e raised to power minus 2, that is 0.1353. Then for getting at least 2 mistakes, so 1, it means 2 and more than 2 mistakes we are to calculate. So total mistakes minus 0 mistake and 1 mistake, if we will detect total mistakes from 0 mistake probability and 1 mistake probability is over there. So the remaining will be 2 and more than 2 defective which over there. So we are having that there are 40.59 percentage of probability there should be zero mistake or 1 mistake. So the remaining 59.41% over there may be having more 2 or more than 2 defective which over there. Next question, one more question related to the Poisson distribution. So it's very easy. In Poisson distribution, you should be follow what the question is saying, then you can solve the question, no problem at all. A toy factory average out of 1 out of 10 is defective. Okay, suppose in a TV factory, out of 10 1 is defective. So 9 upon 10 is what I am saying. In a TV factory, out of 10 TV, 1 TV piece may be manufactured as a defective. Company is producing 10 unit of a batch. Then calculate the with the help of the Poisson distribution, calculate the various constant of this. So the very first we will see the arithmetic mean m is equal to np. So n is equal to 10, p is equal to 1 by 10. So the m value is 1. So standard deviation is root m, that is root 1, that is 1. Standard deviation square, that is m, standard deviation square will be 1. Now skewness, if we are to calculate, that is root beta 1, that is beta 1, that is 1 upon root m, that is 1, that is also 1. And kurtosis, that is 3 plus 1 upon m. So 3 plus 1 upon 1, that is 4. So the constant value we can calculate. What the question is saying, in a TV factory, out of 10 TV, 1 is found to be defective. The TV is producing in a 10 batch. Then calculate exactly 2 defective piece with the help of binomial distribution and with the help of Poisson distribution. Okay, we are to calculate first one. So here m is equal to 1. So e raised to power minus 1, we will see the table for e raised to power minus m. Sorry, we will see the table of e raised to power minus m. We have available, the table is over there already. That is 0.3679. 0.3679. So probability of getting exactly 2 defective with Poisson distribution, that is e raised to power minus m, m raised to power 2 upon factorial 2, that is 0.3679 multiply 1 raised to power 2 upon 2. So that is 36788 is over there in table value I have seen. So we can write 788, no problem at all. So 0.36788 divided by 2, so 0.1839. 0.1839. So with the help of the Poisson distribution, we are having 0.18394. Now this is Poisson distribution. Binomial distribution. We are having, for the binomial distribution, we are having Bernoulli theorem. So exactly 2, that is tan C2 p raised to power 2 q raised to power 8. So 10 multiply 9, 1 multiply 2, 1 by 10 raised to power 2 and 9 by 10 raised to power 8. We have to calculate this. So 45 multiply 9 raised to power 8 divided 10 raised to power 10. So getting the solution of this. How we will solve? We will solve this. The question was asking, a TV manufacturing company found that out of 10 TV, 1 is defective. So the defective is 1 by 10, perfect is 9 by 10. The TV company make the TV in 10-10 base, so the Poisson distribution m is equal to 1 because m is equal to np. So that is 10 multiply 1 by 10, that is 1. So e raised to power minus 1 this, and exactly for getting 2 defectives, so e raised to power minus m and m raised to power 2 upon factorial 2. So 0.36788 multiply 1 upon 2, so we are getting Poisson distribution. Now the same question with the binomial distribution, 2 defective out of 10, so 10 C2 p raised to power 2 is defective and q is clear. So we are having 10 multiply 9, 1 multiply 2, 1 by 10 raised to power 2 and 9 by 10 raised to power 8. Now we have to solve this. So the first one is we are having 45 multiply 0.1 raised to power 2, 0.9 raised to power 8. This also we can having the formula for this. So 0.9 multiply 2 times, multiply 4 times, multiply 8 times, multiply 0.01, multiply 45. So this is 0.1937. So very easily we have calculated 0.1937. So with the Poisson distribution, the probability is 1.1839, but with the help of the binomial distribution, that is 0.1937. So in this manner we can having the comparison between the Poisson distribution and the binomial distribution. Also in this question we have calculated 2 defective probability with the help of the binomial distribution, that is 0.1937, with the help of the Poisson distribution, that is 0.1839 is over there. So the comparison also have done in this question. Now this 1 by 10, that is 0.01, 9 by 10, that is 0.9 raised to power 8. So with the help of the calculator you can calculate this without using the logarithms, because the logarithms having some problem in calculating. If you are not perfect in using the logarithms, then you should having the direct calculation with calculator. One more question related to this. In a factory, it is found that 0.5% product are defective. P is equal to 0.5%, it means 100. Packing are in 100 units. How many units have 0 defective? How many units have 2 or more than 2 is defective? Okay. This question is also related to the Poisson distribution. In a factory, now it have calculated the probability of the defective, percentage of the defective is 0.5. So 0.5 divided by 100. So the probability of the defective is 0.5 upon 100. And the packing are in 100. So calculate. The very first we will calculate M, that is NP. So that is 0.5 upon 100 multiply by 100. So that is 0.5. So e raised to power minus 0.5. So we are having, we will see the table value. For minus 0.5 we have given in this question, that is 0.6065. In question this is given 0.6065. Now we are to calculate exactly zero defective probability for the zero defective, that is e raised to power minus m raised to power 0 upon factorial 0. So that is 0.6065 multiply 0.5 raised to power 0 upon factorial 0. So that is 0.6065, or we can say 60.65% are zero defective. First one we have calculated, that is 0.6065. Now 2 and more than 2. Second we are to calculate probability of 2 or more than 2. We can having probability of greater or equal to 2. So that is 1 minus probability of getting 0 plus probability of getting 1 defective. So 1 minus probability of getting 0, that is 0.6 e raised to power minus m raised to power 0 upon factorial 0 plus e raised to power minus m raised to power 1 upon factorial 1. So that is 1 minus 0.6065 multiply 0.5 raised to power 0 upon factorial 0 plus 0.6065 multiply 0.5 raised to power 1 upon 1. So that is 1 minus 0.6065 plus 0.3032. So that will be 0.6065 plus 0.3032. So 1.9097. 1.9097. That is 0.0903 or 9.03%. So in this manner we can calculate if any type of the question related to the Poisson distribution is over there. With the help of this video you may be able to solve any of the question related to the Poisson distribution is over there. So I think this video will be helpful for you in calculating Poisson distribution if any questions related to the Poisson distribution is over there. One more style of the question of the Poisson distribution is having for that chi-square test in a Poisson distribution. Number of defective, that is 0, 1, 2, 3, 4 and 5. Actually original defective finds 6, this find 13, 16, 8, 4, 3 among 50. One more question related to the Poisson distribution. In a factory, it is observed that among 100, 6 have 0 defective, 13 have 1 defective, 16 have 2 defective, 8 have 3 defective, 4 have 4 defective and 5 have 3 defective. With the help of the Poisson distribution, calculate whether this data is correct or not. So for calculating the correct data, firstly we will having fx, that is 13, 32, 24, 16 and 15. So the firstly we will add these data for getting m value. 13 plus 32 plus 24 plus 16 plus 15. So that is 100. So arithmetic mean is equal to sigma fx upon sigma f, that is 100 upon 50. So that is m value, that is sigma fx upon sigma f, that is np, that is 2. So m value is 2. So e raised to power minus m, that is e raised to power minus 2. So table value in e raised to power minus 2, firstly we will calculate the table value, that is 0.1353. This is given 0.1353. So among 100, firstly we are calculating zero defective, that is n e raised to power minus m raised to power 0 upon factorial 0. So that is 100 multiply 0.1353 multiply 2 raised to power 0 upon factorial 0. So first is 13.53. So first will be total number is 50, not 100. 100 are the total defect. So first one is 0.1353 multiply by 50. So first one is 6.765. 6.765. So first estimated frequency, that is 7. Probability of getting one defective, that is n e raised to power minus m raised to power 1 upon factorial 1. So 50 multiply 0.1353 multiply 2 raised to power 1 upon 1. (13.53) or we can having 14. So second one is 14. Px is equal to 2 defective. So n e raised to power minus m raised to power 2 upon factorial 2. So 50 multiply 1353 multiply 2 raised to power 2 upon factorial 2. So that will be also 14. Px raised to power 3 defective is n e raised to power minus m raised to power 3 upon factorial 3. So 50 multiply 1353 multiply 2 raised to power 3 upon factorial 3. So multiply by 2 divided by 3. So 9.02 or having 9. And last one, Px is equal to 4, that is n e raised to power minus m raised to power 4 upon factorial 4. So 50 multiply 0.1353 multiply 2 raised to power 4 upon factorial 4. So multiply by 2 divided by 4, that is 4.51. We can write here 4.51, that is 4 or 5 we can write. And last, x is equal to 5. So n e raised to power minus m raised to power 5 upon factorial 5. So 50 plus 50 multiply 0.1353 multiply 2 raised to power 5 upon factorial 5. So multiply by 2 divided by 5, 1.804. So this will be treated as 2. So we use this 4. So that is total 7 plus 14 plus 14 plus 9 plus 4 plus 2, 50. So this is also 50. So what we have done, the very first, the question was saying that at least the 0 defective have 6, 1 defective have 13 items, 2 defective have 16 items, 3 defective have 8 items, 4 defective have 4 items, 3 item have 5 defectives. So total item was 50, but the total defect was 100. So average defect per item is 2. So we are getting this e raised to power minus 2, that is 135. Now for using this Poisson distribution, for getting 0 defective the item will be 7. For having 1 defective the item will be 14. For having 2 defective the item will be 14. For having 3 defective the item will be 9. For having 4 defective the item will be 4. And for 5 defective the item will be 2. So this is we have calculated with the help of, this is the original frequency and we have calculated the estimated frequency with the help of this Poisson distribution. Now with the chi-square test, we will calculate whether the original frequency is right or not. So we are having the original data. We doesn't require this. We require only this original data and estimated data. That is 7, that is 14, that is 14, that is 9, that is 4, and that is 2. So original minus estimated, that is minus 1, that is minus 1, that is plus 2, that is minus 1, that is plus 1. Original minus estimated square, that is 114,101. And original minus estimated square divided by estimated for chi-square test. So 1 divided by 7, 0.1428, 0.1428. 1 divided by 14, 0.0714, 0.0714. 2 divided by 14, 0.1428. 1 divided by 9, 1 divided by 9, 0.1111. 0. 1 divided by 2. So 0.5 is over there. So total is 9.6882. 9682. So the chi-square test we have calculated, that is 0.9882. Okay. Now for calculating chi-square test, degree of freedom, that is n minus 1. So 1, 2, 3, 4, 5, 6. That is 6 minus 1. For the 5 table value we have to see for the chi-square test. So we will having chi-square table. This is chi-square table. And for 5% significance level, for the 5 value, that is 11.070. This 11.070. So this value is 11.070. So here the table value is calculated value greater than 11.070 is greater than 0.9689682. It means H0 is truth. So the original data have no any discrepancy. Original data is right data. There is no difference in calculated data by us with the help of the Poisson distribution, and the data is given original. The difference is 0. So it means we will say the data was right. So with the help of this, we have learned how we can check the data with the help of the Poisson distribution. We can check whether the data taken with the emulators is correct or not. So I think with the help of this video, you may be able to learn how we can use the Poisson distribution in various methods. So this is all from my side in the Poisson distribution. In next video, we will having discussion of the normal distribution. Thank you once again for watching this video.